You think you know what gravity is. You picture a force, a pull, an invisible hand reaching down from the sky. You imagine Earth grabbing you. You imagine space as empty, flat, passive. You imagine gravity as something that acts. This picture feels obvious. It feels unavoidable. And it is wrong. You think objects fall because they are attracted. You think planets move because something tugs on them. You think weight is a property of matter. It isn't. Not in the way you think. You have been carrying this picture since childhood. It's intuitive. It's comforting. It explains just enough to stop you from asking better questions. But this picture quietly breaks the moment you push on it. And when it breaks, gravity stops being a force at all. It becomes something far stranger and far more unsettling. You were taught gravity as a force long before anyone proved to you that it was one. A force is familiar. You push a door, you pull a rope, you feel resistance in your muscles. So when someone tells you the earth pulls on you, your mind quietly borrows that same picture. Something reaches out, something grabs, something tugs. No one tells you what is doing the pulling. No one tells you how it reaches across empty space. But the picture feels solid enough that you stop asking. This is where the mistake settles in. Newton wrote down a rule that worked. It predicted orbits. It explained tides. It let engineers aim cannons and sailors cross oceans. And because it worked, you were handed the story that goes with it, a force acting at a distance. But notice what Newton did not give you. He did not give you a mechanism. He did not tell you what gravity is made of. He did not explain how Earth knows where the moon is. He refused to. That refusal mattered. Because the equation functioned whether the picture made sense or not. Over time, the rule hardened into a belief. The belief hardened into intuition. And the intuition became invisible. You stopped noticing how strange it is to imagine empty space transmitting influence with no delay, no medium, no contact. You stop noticing that every other force you know involves something touching something else. This should bother you. If gravity is a force, then something must be pushing or pulling you right now. And yet, when you stand still, you feel nothing acting downward. You feel pressure in your feet. You feel the floor pushing up. You feel tension in your bones. You do not feel a pull from the sky. This is not a poetic observation. It is a physical one. A real force produces a sensation when it accelerates you. A real force leaves a trace in how motion changes. But here, the only thing you can directly feel is the ground resisting your motion. The idea that gravity is pulling you survives only because it lives in your imagination, not in your experience. And this is where the intuition quietly collapses. If gravity were truly a force like the others, then removing all forces should make you float freely. But remove the floor, remove the air, remove every contact, and you do not feel gravity more. You feel it less. This is wrong, according to the picture you were taught. And yet it is exactly what happened. The story of gravity as a pulling force works just well enough to survive, but it hides a deeper failure. One that only becomes visible when you stop trusting the picture and start trusting the experience. You think falling is what gravity does to you. You imagine a force switching on. You imagine acceleration beginning. You imagine something acting. This is the picture that feels unavoidable. Now remove the ground, not metaphorically, physically. No floor, no chair, no tension in your legs, no pressure in your feet. You are in free fall, and something deeply unsettling happens. Nothing. No force presses on you. No downward sensation appears. No internal signal tells you that gravity has intensified. Your stomach does not feel heavier. Your body does not feel pulled. Every part of you drifts exactly as it would in deep space. This is not a trick. It is not a special case. It is the purest gravitational motion there is. Free fall is motion with no force acting on you at all. This is the moment where the old picture breaks. Because if gravity were a force, free fall should feel like the strongest version of it. Instead, it feels like its complete absence. The only time you feel gravity is when something prevents you from following that motion. The ground blocks your path. The floor interferes. the chair pushes back. That upward push is real. It has direction. It has magnitude. It can be measured, felt, and removed. Gravity cannot. When you stand on the ground, your natural motion is downward. Not because something is pulling you, but because that is the path your body is already trying to take. The ground is what stops you. This reverses the story completely. You are not held down by gravity. You are held up by matter. This is not semantics. It is a structural failure of the force picture. Every other situation in physics, forces cause acceleration away from natural motion. But here, the motion you call falling happens when all forces vanish. That should feel wrong. It should feel backwards. Because it is. The intuition that gravity pulls you down survives only because you rarely experience its absence. Your entire life is lived in constant interference. Remove that interference, and gravity disappears. This is why astronauts float. Not because gravity is gone, but because nothing is stopping their motion. The force you thought was always acting turns out to be something you never feel at all. And once you see this, the word force starts to lose its meaning. Because if gravity does not act, and falling is what happens when nothing acts, then what exactly have you been imagining all this time? You think weight is caused by gravity. You imagine it as a property your body carries, a downward burden, a number tied to how strongly Earth pulls on you. This feels obvious. And it is wrong. Weight is not something you have. It is something that happens to you when your motion is interrupted. Stand on a scale. The number that appears is not measuring a pull from below. It is measuring a push from above. The scale is pushing up on your feet. Your feet push back. The scale reports that resistance. If the scale stopped pushing, the number would drop to zero instantly, even though the Earth has not changed. This is not philosophy. This is how the device works. In free fall, your weight vanishes completely, not slowly, not partially, instantly, and yet nothing about Earth's mass or position has changed. If weight were caused by gravity pulling on you, this would be impossible. Instead, weight only appears when your natural motion is prevented. Your body wants to follow a path. The ground refuses. That refusal creates stress in your bones, compression in your muscles, pressure in your skin. That pressure is weight. This is why an astronaut orbiting Earth is weightless, while still very much under Earth's influence. And this is why someone standing still on the ground is not. One is allowed to move. The other is constrained. You were taught to imagine gravity as a force that gives objects weight. But weight is what appears when motion is denied. This flips the causal arrow. Gravity does not give you weight. The ground gives you weight. This should disturb you, because it means one of the most familiar quantities in your life is not fundamental at all. It is not attached to matter. It is not carried through space. It is a side effect of geometry and obstruction. And once weight loses its status as a basic feature of gravity, the last intuitive anchor begins to drift. If gravity neither pulls you nor gives you weight nor acts when you fall, then what is left of the force you were so certain existed? You think gravity bends paths by pulling on them. A thrown ball arcs downward. The moon curves around Earth. You imagine a constant tug, quietly redirecting motion. This picture feels precise. It is deeply misleading. In physics, the most natural motion an object can have is a straight line. No forces, no correction, no guidance, just straight. So if gravity were a force, objects under its influence would be constantly pushed away from that straight path. But free-falling objects are not being pushed at all. This is the contradiction. The ball leaves your hand. After that moment, nothing touches it. No force acts on it. And yet its path curves. This should not be possible unless the straight line you are imagining is not the straight line the universe is using. You picture space as flat, like graph paper, like an invisible grid extending everywhere. In that space, straight lines behave the way you expect. But gravity does not live in that space. The motion you call curved is actually the straightest possible path through a geometry you are not used to picturing. The ball is not being pulled down. It is moving forward in time, following the shape of space itself. The moon is not held in orbit by a tug of war. It is falling freely, forever, along a straight path that never closes. What looks like curvature is not caused by force. It is caused by the rule of distance, and time being different from what your intuition assumes. This is where the word straight becomes unreliable. Straight relative to what? Straight according to which ruler? Straight measured by which clock? In ordinary life, these questions do not matter. On cosmic scales, they become unavoidable. The path of least resistance becomes the path of least action. And the path of least action is not drawn on flat paper. You were taught to imagine gravity as something that bends trajectories. But trajectories are only bent if you insist on measuring them with the wrong geometry. Change the geometry and the force disappears. The curve was never in the motion. It was in your expectations. And once you accept that, the idea of space as a passive stage begins to crumble. You imagine space as something that simply exists, a container, a backdrop, an empty arena where events take place, objects move through it, forces act within it, space itself stays out of the way. This assumption feels so natural you rarely notice it, and it is doing almost all the damage. If space were merely a stage, then motion would be defined independently of what occupies it. Straight lines would be universal. Clocks would tick the same everywhere. But gravity refuses to cooperate. The moment you accept that free fall involves no force, you are forced into a different conclusion. Motion itself is being defined locally. What counts as not accelerating depends on where you are and how mass is distributed. This is not a small adjustment. It is a structural change. Near Earth, the straightest possible path tilts downward. Far from Earth, it does not. Nothing is acting differently on the object. The rules of motion are. Space is no longer a neutral container. It participates. And once space participates, time cannot stay separate. Clocks closer to Earth do not agree with clocks farther away, not because something interferes with them, but because the geometry they live in is different. Time stretches, distances distort, straight lines stop lining up. You do not notice this because the effects are small. But small is not the same as non-existent. Your intuition assumes there is a single global definition of rest and motion. Gravity makes that impossible. Every falling object carries its own local definition of straight. Every clock carries its own rhythm of time. This is not because the object is special. It is because space and time are no longer passive. They respond. You were taught to imagine gravity as something added on top of space, a force layered over an otherwise simple structure. The reality is the opposite. Remove gravity, and space regains its simplicity. Add mass, and the structure itself changes. Once you see this, asking what causes gravity starts to sound like asking what causes straight lines to be straight. The question dissolves, because gravity is no longer something that happens in space and time. It is something that happens to them. At this point, the word gravity should feel unstable. It no longer pulls. It does not act during free fall. It does not give objects weight. It does not bend paths by force. So what exactly is it? This is where the discomfort sharpens. In the modern picture, gravity is not something you can point to. It has no location, no substance, no switch you can turn off. There is no gravitational stuff filling space. Instead, there are rules. Rules about how distances are measured. Rules about how clocks tick. Rules about what counts as straight motion. Gravity is the name you give to the fact that these rules change from place to place. Nothing more. When you say gravity is strong here, what you really mean is that nearby straight lines converge faster. When you say gravity is weak there, you mean they barely converge at all. This is not a physical interaction in the usual sense. It is bookkeeping, a way of keeping track of how geometry differs from the flat picture your intuition prefers. This is why gravity is so hard to unify with the other forces. Electromagnetism acts on objects. The nuclear forces act inside objects. Gravity does neither. It rewrites the stage direction. And this is why asking for a graviton, a particle that carries gravity, feels subtly wrong. You are trying to package geometry into a messenger. Feynman was deeply uneasy about this. He accepted the equations. He trusted the predictions. But he never pretended the picture was comfortable, because once gravity becomes geometry, explanation itself changes character. You stop asking, what is pushing? You start asking, what does motion even mean here? And the answer depends on where you are. This is not a failure of imagination. It is a warning. Gravity may not exist as a thing at all. It may exist only as a relationship between measurements, between clocks, between rulers, between paths that try to stay straight. If that is true, then gravity is not a fundamental interaction. It is a symptom, a sign that space and time are not what you thought they were. And that realization should not feel satisfying. It should feel like the ground quietly withdrawing beneath the last place you were standing. At the end of all this, there is no clean picture waiting for you. That absence matters. Feynman never pretended that gravity had been made intuitive. He accepted that the mathematics worked. He accepted that the predictions were unmatched. But he did not mistake success for understanding. Because once gravity stops being a force, explanation begins to thin out. You are left describing how motion behaves without being able to say what makes it behave that way. You can calculate paths. You can predict clocks. You can navigate spacecraft across the solar system and still not know what gravity is. This is not a failure of physics. It is a confrontation with its limits. The old demand, tell me what is really happening, assumes there is a story compatible with human intuition. Gravity suggests otherwise. Space and time do not curve inside something else. There is no deeper medium bending them. There is only the fact that measurements refuse to agree globally. This is not a mechanism. It is a condition. Feynman was honest about this unease. He did not soften it. He did not offer comfort, because the discomfort is the insight. Gravity forces you to abandon the idea that reality must be built from things acting on other things. It invites a colder possibility that relationships come first and objects are secondary. You fall not because something pulls you, but because motion itself has no universal definition. The universe does not owe you an explanation that fits inside your mental pictures. It never did. And gravity is the clearest reminder of that. Not because it is mysterious, but because it is precise. It tells you exactly how things move while refusing to tell you why in the way you want. And that is where the story ends. Not with closure, not with resolution, but with the quiet realization that the deepest laws of nature may be less like forces and more like constraints on what can be meaningfully said at all.